N is 10. P is 0.2. X is 2, right? We're looking for probability of X equal to 2. So that will be N factorial divided by X and N minus X factorial times P to the X times 1 minus P to the 10 N minus X. So that's how you do that, right? And with this calculation, you get 0.302. That's wonderful. Yeah. What if I ask you to find out what is probability of X less than 2? That's similar to what I shown you in the example, right? You just find the probability of X equal to 0 plus the probability of X equal to 1. Okay? Use the same kind of formula. Okay? Actually, for 0, I just calculated. It's 0.107374, right? On my calculator. For 1, it's 268.35. So the total is, let me see, the total is 375, around there, right? So that's, if you were asked, what's the probability of having less than 2? What if I ask, what's the probability of at least 2? Well, you use a complementation rule, right? At least 2, that means 2 or higher. That's just 1 minus probability of less than 2. Right? That is 1 minus 0.3758. So it'll be 0.6242. That'll be your answer. Right? So that actually covered the next question I want to show, but that's how you do it, right? Okay, so that's easy. Can I flip it to another one? Or is you copying? Okay, let's wait a few seconds. Right? Okay, any question? Good. Now let me flip it to next question. I'll let you try first. Patients arrive at an emergency room of a hospital at the mean rate of 3 per 20 minutes from 10 a.m. to 2 p.m. Assuming that the patient's arrival follows a Poisson process, and assuming that rate keeps steady, right? There's a steady rate. Find the probability that 2 patients will arrive between 11 to 11:20. That's just a 20 minutes period, okay? What's the probability that you find you will have 2 patients arrive in this emergency room in that period? So what model should I use? Binomial or Poisson? Poisson, right? This is number of arrival per time period. There wasn't any sampling, right? Just, Anybody got an answer? 0.07?
0.075.
0.075? Okay. Anybody has the same answer? All right, keep working. All right, if you haven't finished. The lambda is what? 3, right? And x is 2. So we have e to the minus lambda, e to the minus 3, times lambda, that's 3 raised to the x, which is 2, right? Second power. And then divide by 2 factorial. Okay. Two factorial. So the answer will be different, right? Okay. Anybody has other answer?
0.224.
That's right. 0.224 is the correct answer. Right. Okay. Let's see how we do this. Lambda 3. Event of interest is 2. So talking about probability of this Poisson random variable takes on the value of 2. Right? That's another way to say it. Right? And so that's e to the minus lambda time lambda raised to the second power over 2 factorial. Right? If you use your calculator, be careful when you're doing the calculation. Right? It is actually 0.224. Okay. Good. Let's see, what do I have next? It's the same question except for about at least 2 patients will arrive. At least means what? That means what? That means this, right? At least 2 means 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 and 10 and 1,000, millions, and infinity, right? That's so many terms to do it, right? You don't want to do it directly. Remember the complementation rule. This is what you want to do. Okay? That's, you can find the probability of 0 and probability of 1. You need the probability of 2? No, you don't, right? Less than 2. So you find the probability of 0 and probability of 1. Okay, maybe let me get you this. All right, this is 1 minus probability of 0 will be, what I have here is 0.049, 0.0498, around 0.0498. Right? Probability of 1 is around 0.1494, 0.1494. Okay, and you just add them together. Let me do the adding. 0.199. Is that 0.2, right? So that's 0.8008. Wow, that's an interesting number. Okay? So that's, again, it's a review of what we just did, okay, earlier. about this? Okay, the same rate, but we're talking about between 11 to 11:40. Okay, I'm also one of the emergency room doctor, but I want to take a coffee break very quickly. And if only 3 patients, it's okay, right? More than 3 patients, we'll be in trouble, right? How likely will be only 3 patients in that period or less, right? And here I just asked 3 patients, right? What would the probability of this? In this case, something has to be adjusted, right? What needs to be adjusted? The rate has to be adjusted, right? You were talking about 20 minutes is 3 patients. But here we're looking at a 14 minutes break, right? 14 minutes interval. So the lambda, in this case, lambda will be, originally it was 3, but we're talking about twice the time interval. Twice of 20 minutes. So the lambda will become 6. The rate of arrival, right, be 6. Right? And we're interested in the probability of seeing 3 patients. So x is 3. So we're talking about probability of this Poisson random variable takes in the value 3. Or the probability of have 3 patients arrive in this 40 minutes period. So the same thing, e to the minus lambda raised to the x power divided by x factorial, right? That will be, let me move it up a little bit. That will be how you do it, right? So if this is 3, and we lambda is 6, so what's the probability? Anybody? I'll give you the number. 0.089, around. I hope I calculated right. I think so, right? Any question? Okay, good. Now, let me pull this out. Okay, so let's look at this problem. How do we solve this problem? What kind of model should I use?
What's the
20%
Hey,
of...
Andy, this is Amy over in Akron. Your screen is flickering back and forth. What media are you using? Are you still using your document camera?
Yeah. It's not clear there?
Okay, it just stabilized. It seemed to be flickering back and forth. Thanks.
Okay, good. So hope you can read it. Actually, again, 20% of people live in the community that have disease. If you take a random sample of 100, what's the probability that less than 10 of these are less than 10? I'm making it too hard, right? How about make it easier? 10 of the 100 people have disease. Okay, don't try to do this, right? Because 100, that's n, right? So you talk about 100 factorial. Some of the calculator may not be able to handle 100 factorial, okay? So there's a trick to this kind of problem. Now, the binomial distribution and Poisson distribution and that normal distribution that we learned, they're somewhat connected, okay? When the sample size is large enough, when the proportion of success reaches a certain level, 10 or higher or 5%, then the Poisson model can be used to approximate the binomial distribution. Because the Poisson is like perform infinitely many binomial experiments, right? I mean, Bernoulli trials, right? And at a certain time point, you have one success and then so forth. So in the time interval, you observe 3 or 4 successes, right? So when the sample size gets large, Actually, you can use Poisson to approximate binomial. Okay. So in this case, if you want to do it, this is actually originally it's a binomial problem, right? We have a rate of success 0.2. Okay. And number of trials n is 100, right? 100 factorial. If you have regular scientific calculator, try it. It doesn't work, right? Too large a number. Now, with these two, I can figure out the mean of this distribution. Remember, what's the mean of a binomial distribution? N times P. So that's 20, right? Now, if you want to use a Poisson probability model, Poisson probability model has only one parameter, that's lambda. And that lambda is the mean, okay? So you can use a Poisson with lambda equal to 20. And you can solve this problem, okay? So I just let you carry this home and try it, right? See if you get the same chance of 10 successes, right? Would it be equal to binomial? You can try binomial using a computer or using maybe a graphing calculator. Probably it'll help, right, to solve this problem. Okay. And when you do binomial, you have let's say when you do 100 factorial divide by 10 factorial and 90 factorial. That's the first part, right? Try not to use calculator if you have small calculator. Do it. Try not to do the factorial. Try to do this. 100 is 100 times 99 times 98 and up to 91, and then 90 factorial. And this 90 factorial and 90 factorial cancel. So you can have these two numbers multiplied. That's a manageable number, right, if you want to do the binomial one to check your answer. Right? You'll find out that these two results will be about the same. Okay. And when sample size is really large, actually normal distribution is a good approximation for this. In fact, if I change this question to less than 10, right, that would be a hard problem if you still use Poisson approximation. You have to calculate probability of 0 and 1 and 2 and 3. That's a lot of computation. What we can do is actually use a normal distribution that means the same as this, 10 or less. Try to figure out the area below 10. That would be a good approximation, right, for this binomial probability. Okay? The reason for that is because of a theorem called central limit theorem, and we will talk about that later. All right? Binomial experiment is a sum of outcome from a sequence of Bernoulli random variable, or random Bernoulli experiment. Right? When you have a sample of Bernoulli random, actually sample of any distribution, random sample of any distribution, if you sum them up, all right, it has a normal distribution, approximate normal. We'll talk about that later on. Right? So this is just, just something I thought worth to bring it up. Okay, let's look at another one. This is something that we covered, the last part we covered, the normal distribution. Okay, can you try this using your normal distribution table? If you finish that very quickly, you can then try the next one, right? Let's try it and bring your table up, and then you can also discuss with your neighbors, your friends, right? This is a good chance to actually study together. Or if you know how to do it, explain to your neighbor, right? That's a good way of learning, right? You reinforce your knowledge, right? And learning is, of course. Okay. Okay, anybody has the answer to the part A?
.894
Yeah, eight.
for A and
Point
B
894?
0.78.
Is
Yeah,
that right?
89.4%.
Okay, good.
The probability percentage is 89.4.
Okay,
And for B, it's 0.782.
782.
Yes.
Okay, good. So let me do this, all right? Let's show this. When you solve these kind of problems, the first thing you want to do is draw a normal curve to understand what's the event like, right? What's the region like? You have a normal curve, point of symmetry, mean is 70, and standard deviation is 4, okay? So you're interested in finding percent of population possibly less than 75. So let's say this is 75. What proportion of them lies below 75? That's the question, right? This is the original variable.
2.8. I mean,
0.688.
Okay? Now, we want to standardize this. So if you standardize 75, z-score of 75 is 75 minus mean divided by standard deviation. So that's 1.25. The z-score is 1.25. Of course, mean standardized is going to always get 0. Okay? But this number is good enough because then what I would do, I would cover this up. Assuming this is just a standard normal curve, right?
And second one?
What proportion of distribution below 1.25? That's it. Okay? And what you need to do actually is find out what this is. I believe that's 0.106, right? When you look up a table, right, that's what it is. Right? When you check the table, let me zoom it in a little bit. 1.2 and 5. Actually, well, hold on.
one is in fact
1.25, 0.106. Okay? So that's how we get this 0.106. And then the actual distribution less than 75, just 1 minus this number because we're interested in this region, right? So that 0.894. That's the answer. Okay?
78.8.
68.8.
78.8. It's 78.8.
Yeah, 78.
78.8.
Okay. I think that's probably from somebody's microphone from Cleveland, maybe still on or something. Anyway, so part B, between 65 to 75. Again, you like to draw a picture. Mean is 70.
Actually, B is 0.788. I did a little bit of a mistake.
Okay, it's okay. We're gonna figure it out. Thanks. Because you give us this answer, give us more confidence, right? We know that there's an answer, right? Okay, 65 to 75. Now notice that the distance from here to here and here to here are the same. So if I can find this piece, I would know this one, all right? And there are so many ways to do this. In fact, people say, oh, if I found this one will be the same as that. So I just use 1, subtract twice of that. I get the answer. Right? So let's do that. Right? This is the original score. So let's find the z-score for it. For 75, what's the z-score? 1.25. We got it there, right? For the previous problem, the z-score for 75 is 75 minus 70 divided by 4. Right? That's how we get this. And the z-score for 65 is 65 minus 70 divided by 4. That's negative 1.25, right? So this is negative 1.25. Again, if I cover this up, the question is really find the area in between negative 1.25 and positive 1.25 under standard normal curve, right? So what I need to do is find out what this is, and this will be the same as that. So I subtract twice of that tail area, and I get my answer. Okay, so I know this tail area already. This is 1 0.106 from the chart, right? So the probability of this value lie between, oh, did I use, I'm sorry, I should use x, right? This is x. X denotes the original distribution, right? Z is this notation I use for standard. So this is actually saying the same as saying the area under the standard normal curve lies between negative 1.25 to positive 1.25. That's 1 minus twice of this tail area. That's 1 minus 0.212, right? So that's 0.788, right? So that's the answer.
Dr. Chang,
Yes.
Kent, we're frozen again.
Oh, is that right? Okay. So what
We're
can
gonna
we do
reboot.
then? Okay.
I'll let our tech know to reconnect.
Okay. I hope it was frozen at another time point. Let's see. So Ken probably can't hear us either, right? Since they're rebooting. Well, anyway, let me put this on, okay? This will be easy, I guess.
Dr. Chang,
Yes?
can you go back to the other problem? Sorry.
Sure.
Thank you.
Can you see it? Okay. Let me see.
Yep, thank you. Dr. Chang,
Yes?
the screen is flickering. We can't really see too well. I don't know why it's doing that, but oh, there we go. Thank you.
Okay, it's a connection here, that is. Okay. Good. Okay, yeah, move it up a little bit.
We're working on getting Kent reconnected. Should take hopefully a couple minutes here.
Okay. Okay, I guess.
And are you guys back?
Yes, we're all set.
Okay, thanks. Okay, for Kent, this is these are the two more questions. What percentage of population have pulse rate higher than 80? I think this is easier, right? Find the z-score for 80. That should be a number that is positive, and find out what's the area above it, right? That table gives you that directly. 90th percentile. First, you have to figure out the z-score for 90th percentile. So, anybody has an answer for C?
For C,
Mm-hmm.
It's 0.6%.
0.6%.
0.6.
Percent.
Percent.
0.6%. Okay.
Yeah.
Which is
For
0.006.
75.12.
Or 0.006. Yeah. Pretty much just you find well, let me draw a picture. 70, 80 is here. This is original. You find a z-score for it. Z-score for it is 80 minus 70 divided by 4. That's 2.5, right? So the z-score for this is 2.5. You just look up 2.5 z-score in the table. 2.5 give you 0.006, right? Look up a z-table, or standard normal table for 2.5. That's 0.006, right? So you get that number. Good. So the probability of higher than 80, we got the answer. 0.6%. So probability of less than 80 is 99.4%. Okay, that's easy. Okay. By the way, where's my first one? What's the answer to the first one? Let me see. Where's my first one? I couldn't find my first one. First one, less than 75 is 89%. That means 75 is the close to 90th percentile, right? 75 is like 89.4 percentile. Okay, so hope you know that, right? So let's say in the population, yourself has a score. You want to know which percentile you're at. If you know the mean and standard deviation of distribution, then you know what it is. Given that it's a normal distribution, right? If it's not normal distribution, it'll be different. Okay, good. How about 90th percentile? Did you find that 90th percentile?
75.12.
75 points. Okay. That should be very close to 75, right?
In fact, 74.8.
Is that right? Okay, so let's see. We have a debate here, right? Let's look at this result here. We have a 75 whose percentile is at about 89%, right? So you have a 90 percentile. Should that score be higher than 75 or less than 75 first of all? 89th percentile is around 75. 90th percentile should be higher or lower? Higher, right? Right. So if you have an answer, one is smaller than 75, one is higher than 75, you're going to choose the one that's higher than 75, right? So you have an MCAT exam or whatever exam, you have multiple choice, and you have, well, anyway. So let's do this. All right. Normal distribution, we're going to start with a standard normal to figure out z-score for the 90th percentile. So if this is 90th percentile, this area should be 0.1, right tail area. Actually, we have a notation, special notation for this kind of z-score. We call it z of 0.1. Right? Z of some subscript alpha is a z-score such that The right tail area is alpha. Right, so sometimes we call it Z.1. Now, it depends on book. Some of the textbooks prefer to show the cumulative distribution and the subscript. So you may see people say Z.9, all right, and it's like this, right? So it depends on book. There are two versions of these subscript things, right? In the book that we use right tail area as a subscript. Okay, so this area is 0.1. So what should you do then? If you want to find this Z-score, you come to the table, look for a number that right tail area is close to 0.1, right? So 0.1. Do we have a number that's closer to 0.1? Actually, we have 1, 2, 3, 4. Huh. That's tough, right? Which one is it? Now, usually when we have this, now these numbers are not exactly 0.01, you know. It's 0.01, 0, maybe 6, whatever, right? And just run up to this. So usually when situation like this, I will find the midpoint, okay? Or 2 of the middle value, right? So this is 2.31, 2.32, 2.33, 2.34. So you may pick 2.325 if you like to, right? That's the midpoint of 2.21 to 2.24. Am I making sense? You have so many of those. 0.01, 0.01, 0.01, 0.01. You have 4 of them. What's the Z-score?
A Z-score.
I'm sorry. Look at the wrong thing. 0.1, right? Ah, okay.
It's 128.28.
Where is it? Here.
1.28.
Here. We have exactly one, right? 1.28. I get somebody. Anyway. 1.28. Good, right? So 1.28. So this is 1.28. Good. We're almost done, right? We got a Z-score for this 90th percentile. So what is the Z-score then? I mean, what's the actual score? The 90th percentile. This number tells us how many standard deviation is this percentile from the mean. Mean was 70 plus this many standard deviation, right? So that's 70 plus, actually this is what, 5.12, right? Am I right? Okay, so that's 75.12. It'll be greater than 75 because 75 is at the 89 point some percent, right? So 90th percentile should be higher than that. Okay, good. Any question? So you can feel very comfortably do these quiz. What's it? Quiz number 3 now, right? It's all about these material. Okay. So we learned actually more than 3, but the 3 more important distributions are binomial, Poisson, okay, and the normal distribution. Binomial has parameter n and p. N is sample size, p is probability of success in each Bernoulli trial. What's the mean of a binomial distribution? N times p, right? For that distribution, there's a mean. There's a variance too, n times p times 1 minus p. And the standard deviation, of course, is square root of variance. Okay. We have a Poisson distribution. That model has a mean also. That mean, we call it lambda. Okay. Poisson has variance too. Very strangely, the variance and mean are the same. Okay. Normal distribution has mean and variance. Okay. But when you do normal distribution, use that standard normal table to take care of all the prob. For the binomial Poisson, you have those probability mass function that can help you to calculate the probability. Right. So they're not too hard. Right. You play with few problems. This is a piece of cake. Right. But they're useful in the future. It depends on how far you're going to go with statistics. Right. These models will come up, right, in the more advanced statistical modeling course. Right? It's good to understand the background of those. And also, when people mention it, you know the terms. That would be great, right?